records. It's here. It's here. And then, so let's go to classification model, okay? Yeah. Come on, open. There we go. So this is the package structure, okay? I'll show you what this means as we progress. But I wanted to have a look at Titanic model, okay? And see where I put files. For example, the dependencies and importation and so on, you know, these can be put anywhere, but I tend to put them, for example, under maybe, let's have a look, under, so in the beginning, if you have any data, we put it under the datasets folder. Okay, that's the raw data.csv. And if you have any configuration, you might have spotted config. So we have a config folder, and there I have a Python script that has this configuration here. Now, this configuration is coming from the package called pedantic or pydantic in Python. Okay, and this helps you model your problem and create the configuration. For example, this is what we call application level configuration, where you can add package name of type string, raw data file of type string, and then the pipeline save file of type string. This is so that you know where to save your pipeline and where the data file is. And then the package name, these are all of type string. And then here, this is configuration relevant to the model training and feature engineering. So the target variable is of type string, at least the name of the variable is string. If you have any unused fields or the features are sequences, the test data size is of type float. Random state, remember when we spoke about reproducibility, so random state is to fix the random seed. If you have any numerical variables, categorical variables, and the cabin variable, okay, remember we put them into capital variables there, now we add them to our configuration, okay? And now, this is basically a master config object. I'm assuming we know Python and Python OOP. It is a simple class. And then here, we have a few helper functions that can help us find, for example, the configuration file. And notice we're using Python type hints here. I don't know whether you've seen this stuff before. So this is of type path. And you see that this is coming from the path lib. And then the type sequence is coming from the package called typing. And even when we deal with the YAML, we have a nice package called strict YAML in Python. Okay? And by the way, something I didn't mention here, we put our project directories. Okay, so for example, the package root folder, the root folder, the configuration file path, so where to find the config.yaml file, where to find the datasets file, and where to the datasets folder, and where to find the trained models folder. Okay, and these are, like we said, helper functions. Okay, like we said, we have provided plenty of declarative comments so that it makes sense. Now, for dealing with the data, you can go to, that's the config. And by the way, you can see the config here is done in a YAML file. It's not a Python file. This is because we want to reduce the power of these files. So because a Python file can be executed, whereas a YAML file is a plain text file, then whenever you can, always make sure that you use a plain text file. Okay? So this is the package name. Notice these are configuration variables, okay? Package name, we call it Titanic model. That's the raw data file. If you want to split the data into train test in advance, it's fine. You just put the file names here, okay? The target variable is called survive. The column is called survive. That if you have a look at the raw.csv, you'll find it. And then these are the features we have. Oh, sorry, the pipeline name is Titanic classification model, and then the saved file, this is where we later on build the model and save it. We'll give it this name and then a version number. Now, where we save it, remember the config here, we'll save it under these paths, okay? Under this path here. And this is where we find the data, and this is where we find that config.yaml file, which is this one. I hope you can see the link between coding these things into the package so that the package automatically finds any file it wants. Okay, that's for configuration. Like we said, if you have data, then you can create a data manager file if you want to apply anything. But here we're going to do the split on the fly. So we'll split the raw data file into train and test. And you might have spotted in the config file, in the YAML file, that we specify the test size and we specify the random state. This is to guarantee reproducibility. Okay? And then we know that these fields are not used, so we'll hard code them or I'll list them under a category called unused fields. These are the numerical variables, age, fair, and so on. These are the categorical variables, sex, cabin, and so on. And this is the cabin variable. This is a variable that we'll have to pay attention to because we want to extract only the first letter of the cabin column. Right? What else do we have? Now we spoke about the pipeline that we have looked at on the Jupyter Notebook. Now that is saved under its own Python script. This is the same pipeline from before. Okay? But here, notice, we do the imports that we require. And notice we also import the config from the config.core, and also we can also, for example, import our own transformer. Okay? So any pre-processing, by the way, is saved on this column, this folder called processing. Okay, so data manager dealing with features and applying validation. So if you look at the data manager, for example, here is where, for example, we have those functions in case we wanted to prepare our data. This is where we save the pipeline here, okay, and we load the pipeline here. Okay, and as you can see, we have a helper function here that when we want to save the pipeline after we apply training, we delete any existing pipelines and then only save the most recent one. We can have a look at features. This is where we write our own transformers. Okay, so from typing, for example, we can import list, import pandas, import base estimator, transformer mixin, and then write our own transformers. Okay. At first, this might look a bit complicated, but this is, like we said, a professional way of packaging up your model. And then you can apply validation here, for example, and these are also almost like using what we call schemas. Okay, so for example, the P class column is of type int, the name column is of type string, the sex column is of type string, the age column is of type int, and so on. So it's like almost like schemas. So this is one record in your data. This is when you feed the data into the model. This is one record. And now if you wish to maybe send the model a full data frame of data of records, then it's a sequence or a list of these schemas. I hope the idea here makes sense of using the schemas. Okay? You have the base model from Pedantic, and then you define your data schema, and now you have the inputs now is going to be a list of these guys, because you have multiple records in your data, and each one of them represent each record should adhere to this schema. Okay, so let's go back to our pipeline. These are the imports. So from feature engine, we can import, for example, one encoder, rare label encoder. We can import these guys for imputations, and we can also import our own transformers. And then remember, we import the config, so because we have everything inside the config. See now, instead of hard coding the column names or the variables, we can call them from config. Remember the numerical variables? We saw them under config, YAML, these guys. That's how we professionally call them under your pipeline. Okay, so you don't hard code them here to cut down making mistakes. So you only need to update the config file if an update is needed. Okay? And then this is where we apply training. This is where we run the training. See, it's in a separate script because of software engineering standards. Remember, we reduce everything into one purpose. So every script does one purpose. That's why it's broken down into multiple scripts. Okay, this is where we apply the train test split. We get the feature names from the configuration, the target variable name from the configuration, even the test size from the configuration, and the random state from the configuration from this YAML file again. There you go. Okay, and then you can trigger training. And then the train model will be saved here. Okay, these variables will not exist. These ones is just because I've run training before. Usually, let me actually go to the folder. Okay, I go to the folder. Usually, you will have, so you won't have this. Okay, you can delete this side. Keep requirements, keep tests, keep the model, and then also you don't have this. So you only have requirements, test, and Titanic model. The requirements folder, by the way, the requirements folder, where is it? Here. Yeah, the requirements folder will contain text files that contain requirements. As you can see, if I zoom in a little bit, I'm specifying versions that we're going to be using. So numpy between this version and this version, pandas between this and this, pedantic, scikit-learn, strict YAML, Romul YAML, feature engine, and job-lib. Later on for testing, we'll need these packages, okay? We'll need the package called black for code styling, flake 8 for linting, mypy for type checking, and then isort to make sure our imports are in the correct order. Okay, this is, like we said, professional Python stuff. So we pay attention to everything, even to the order of importation, package importation. Okay, remember type checking, flake 8 for linting, and then black for code styling. And then we're going to be using the PyTest for testing. Okay, so please pay attention to this. Take your time when you study the structure of this package. I have to say, it might be new to you. It might be something you've not seen before. Take your time when you actually study it. Okay, so let me go more into this stuff. So the setup file here is quite helpful, and this is where you specify details of your package. Now you might say, and please pay attention here, you might say, oh, this is very advanced, this is too difficult for me. I'm going to tell you something that's really useful, and that is, you don't have to write anything from scratch, because you have access to this code, so you can customize it to your package. You don't have to write this stuff from zero. Okay? So you don't, please pay attention, you do not have to write this stuff from zero at all. Okay? You can use this stuff, for example, change the URL, change your email, change the author name, change which Python version you want, and then these are just configurations, for example, for the root folder, where the requirements are, the name of the package, where the model is, the version file, and so on. And you might have noticed that we have under the Titanic model, we have a file for the version. So we can add a version here. Now I'm in version 0.0.10. Okay, and this is something I want you to learn, what we call semantic versioning in Python. Okay, we have 3 fields, what each field means. Okay? Please pay attention to this, how to professionally package your Python code. Okay, let me close these files in the professional package. Now, in order to build everything nicely, we have a very powerful package in Python called Dockerization. It's very, very nice. So if you follow the link, Docs is a really powerful package. I cannot explain it today. I'm hoping that you know it already or you can learn it in the future. Okay, but in general, like we said before, it helps you automate and standardize testing in Python. Okay, this is the future, hopefully the future of Python testing, configuration, and even deployment, packaging and deployment. Tox is extremely powerful. And what you do is you create a tox.any file, and then you create environments in it. Okay? For example, and normally this is put in the same folder as the setup.py file. Okay? So you begin with the square brackets. That's the root tox environment. You can say, okay, I'm going to support Python 2.7 and Python 3.6. And then you can add environment as you go. This is a simple file. Like I said, you can read through it in your own time. It's a really simple file. If I show you my tox file here, okay, remember it's at the same level with the setup.py file. If I show you my tox file here, you might find it quite big, but it's actually quite easy to follow. So using tox, we can, even on multiple operating systems. Okay, so you begin with the list of environments you want to run, and then you configure each of them. So here, for example, I'm saying I want you, when I run tox, I want you to run test the package, apply type checks, apply style checks, and apply linting. And now for each of them, okay, I'm gonna prepare some configuration. For example, when I run the test, when I test the environment, I need to install any requirements. When I want to test the package, I'm going to say, okay, these are my dependencies, the requirements files. And remember, the test requirements, if you remember, the test requirements file, we'll go to requirements, the test requirements file actually refers to the requirements file. So it'll, both of them, or the packages in both of them will be installed. Okay, and then here, okay, I'm going to say, set the environment, set the Python path and the Python seed, and then run this command. So run Python Titanic model, train pipeline, and then run PyTest. This is for the test package tox environment. Now for the train one, I just configure it and then apply model training. So run the train pipeline with PyScript. For the type checks, remember the MyPy package. So we use the MyPy package to apply type checks. To do style checks, remember the Flake 8 package, we run the Flake 8 package. For linting, we use iSort, Black, MyPy, and Flake 8 together, all of them together. And then this is this configuration for Flake 8 to ignore or escape some types of files and some warning types. So tox is very, very useful for these purposes. Okay, like I said, you can have a look at it in your own time, but the beauty of this is once you do it correctly, okay, and this is available even here, once you do it correctly, if you look at the documentation here, it says you can install tox, then go into the directory where the tox file is. So classification model, this is my tox file. Excuse me, if I run tox, let me just zoom in a bit. If I run tox only, okay, then if you remember my configuration, it'll test the package, apply type checks, style checks, and linting. If you wish to run train, then you can say tox-e, then the environment you want. So for example, where is train? For example, this one, train. Or maybe test package, apply testing. You can run testing. Now, when you run this for the very first time, it'll take some time because it'll install the requirements and it'll take some time. I have already run it this morning to save some time, and you might check that. I have a hidden folder called .tox, so this is what it's going to create. Okay, so let me run everything in front of you. I'm going to say tox. hit enter. It'll take a little time. Now, if you run, like I said, if you run it first time, see, it'll take several minutes because it's going to be installing the requirements. Okay. In my case, I have already done that to save some time. See, now it'll start to apply the tests. So it'll apply what? Model training. It'll apply tests via PyTests. Now see, the tests are passing. Yeah, tests are passing, and now it's doing my py, so style checks, checking if anything is wrong with my coding style. If you know the pip 8 standard, that's what's being followed here. And then run flake 8. See, now it tells me all done. It has reformatted one file. Okay, the Titanic, under the Titanic model, because the coding style might have been not following the standard, and then now it tells me testing is good, type checks is good, style checks is good, linting is good, all is good. Congratulations, your package is ready. Okay, it's done professionally. Now let me go deliberately and, for example, change something. Okay, let me go, for example, to Titanic model, to maybe features. See, even the spacing between the class and the imports is important. If I add several lines here, okay, and then either run it again, run tox again, or if I go to, what do I have here? Style checks, yeah? So I'm going to say style checks. See, now I'm going to say tox and clear my screen. Tox -e style checks, run. See? It says, yeah, something is not right about the style checks. Let me do type checks. Type. See, that's what happened when I changed that line. See, type checks. Okay, no issues found. So with the type checks, we're good. The style checks, see, now it says we have too many blank lines. See this file here called features, called 16.1 features. See, this type of error, E303, too many blank lines. This is because of the blank lines I have manually added here. You understand, it says you only should have 2 blank lines between the import and the start of your script. So if I run this again, run the style checks, hopefully now it'll be green. See, now it's good. Does that make sense? So it's very strict. Okay, very, very nice. Type checks, style checks. So the type checks is to do with the data types. Remember, for example, when in the configuration we said something should be integer or string, if somewhere else, sorry, not here, if somewhere else, for example, we change the type of any of these guys into something else, it's going to complain. It's tell you, I cannot accept because you've defined it as a string type, it should be of type string. Okay, and we'll see this later on when we do, when we apply, when we, deploy our package, our API, and then feed the data with incorrect values, we will see how it actually works. Okay, so that's for tox. Please make sure you learn tox because it's extremely powerful. Here, I provide some introductory examples so you can, it helps you create your own virtual environments, and then as we have seen, we can configure to run tests, to run the model training, to run type checks, style checks, linting, and so on. If you want to run everything in one go, remember in your tox ini file, you can add them to this list. You can add your environments to the list here. Okay, and that's when you say tox only without the -e, without providing which environment you want to run. Type checks or train the model or apply style checks or linting and so on. Okay? Now the next package I want to speak about is testing with Python tests. That's for docs. Okay, I will come back. So we have done the docs command that applies those steps for us. And we'll see how we can upload stuff to PyPy. But before we do that, let's have a look at PyTest, because PyTest is extremely helpful and really, really powerful package in case you've not come across it before. That's docs. We go to PyTest.org. I remember the link correctly. Yeah, so PyTest is extremely powerful, okay? It makes it easy to write readable tests. You can scale them even if you wish to support complex functional testing. Is very, very good. Okay, so this is like the extension or the next step after the normal Python testing. Now, when you, for example, have a simple example like this, you have a simple function like this, and then you want to test it, so you begin the testing function with the word test and then underscore. You see the assertion here is different when you say, for example, assert equals or assert less than, assert greater than, the stuff we're familiar with the normal Python testing. So, okay, this actually saves you a lot of time in this sense. That's one benefit of PyTest. Another, so you see now, it basically gives you detailed info. Even when failing with assertion statements, it gives you a lot more detailed responses or error messages. Okay? The other powerful thing about it is modular fixtures. Okay? So for fixtures, it's when I was saying Python test, what I mean is unit test and the nose package in Python if you're familiar with it. But one really powerful thing about PyTest is the fixtures. So what you do is you can parameterize your tests, meaning you can, for example, have your, for example, data preparation function somewhere and then pass it as a parameter to testing function, so you can customize your tests easily. Okay, so this is what made me fall in love with this package. Okay, the parameterized testing using fixtures. So this is anybody knows what this is called in Python? Decorator. Okay, using decorators, you can add these fixtures. Okay. So, for example, what this is saying is, this is a test file with a fixture called outer. Okay. Now, this fixture requests an inner fixture from another place, which is this one. So this is the original. Sorry, this is a fixture of a function called outer with the fixture, and then it requires another one called inner. This is one fixture it calls called order. So it's a function that gives it maybe an empty list, and then it requires another fixture. And this way, if you forget about this one, for example, inner, this way you can pass your fixtures to other functions as parameters. And that way you can customize your tests. Okay, so PyTest is extremely powerful in this sense. I want you again to learn about it. Hopefully you can read about it and it'll make sense. Let me show you some of the examples here so it makes sense. Let me close these guys. Okay. And by the way, here I've only provided a couple of tests to show you how it's done. So my testing in this package isn't comprehensive. I want you to run your own tests in the future. This is just to show you how it's done. Okay, I'm sorry. So here I have a function called conf_test, okay, for test configuration. Let me zoom in a bit. You might have noticed I'm using Python logging. Okay, and later on we have a nice package called logoro, which is really, really good for logging. Now, what I do here is I'm importing the package called PyTest. I'm importing the train test split. I'm importing the config so I can have a look at the random state, the test size, and what's the target variable, and so on. And now, what I'm doing here is I am creating this function as a fixture that is going to load the data. This function, remember, is coming from the data manager, okay, to load the data, and the data file, the data set file name. Remember that raw.csv is under configuration, okay. So you don't manually pass the file name. Now you just use those variables from configuration. Load the data, the raw data. Apply train test split with all the parameters from the config file, and then only return the X test data, only return the test data. Okay? Now, if you see my tests, here, I'm importing the config, and I'm importing the extract letter transformer from the module features. And what I'm saying here, if you remember, we said for the cabin variable, we'd like to extract only the first letter. So we'll apply the extract letter transformer on the cabin variable. That's how we configure it. Okay? And now what we'll do here is we'll get the sample input data, which is the same as the function name. Remember, because this is a fixture, now it'll give me the X test data. Now what I'm doing here is from the X test data, I'm taking the cabin column and I'm taking the 7th row with ID 6. Remember, ID index values start at 0 in Python. Okay, and I'm saying, okay, assert that the value there is E12. So that's true. And I'm saying, so this is, by the way, a given when then testing style. Given this data, and now when I apply the transformation on the sample input data, then I should get that the value at the 6th row of the column cabin is E only, because the transformer only extracts the first letter. So now we're learning two things at the same time. We're learning how to write the test using PyTest, using the given when then example, and also using the fixtures, the function, this function here, okay, that works as a fixture. Now, in the other test, when I test prediction, let me zoom in again, then again, I am calling sample input data from the test configuration because it's a fixture. So PyTest will use it nicely. And then now I know, because I've run this stuff before, I know that the size of the test set, if I apply 0.1 fraction train test split, is going to be 131 instances. So that's the expected number of predictions. Given that we expect 131 predictions, remember the make predictions function from the model predict module, will pass it the sample input data, so the X test data, and then it'll return the predictions to us. By the way, one thing I wanted to show you under the predictions function, which is under Titanic model, under predict, that the make prediction function, it'll receive the data and then it'll basically apply predictions, but it'll give you a dictionary of results. And the dictionary will have your predictions as a list of values, the version of the actual model, and if there are any errors. Then from that dictionary, if you want to access the predictions, you just access this field. That's why in the test here, in the result, we say get predictions. Give me the predictions, and then you can apply assertion. Okay, for example, this is going to be a list of predictions, and then the values there are of type int, okay, because it'll give you either 0 or 1, and the length of all the predictions is 131. Okay? And then the accuracy, for example, should be more than 0.7. Okay? This is the given when then scenario when we apply testing. Okay, I hope it makes sense here. I know, like I said before, this might be new to you, but hopefully with time you'll make sense of transforming that Jupyter notebook into a professional package. Remember also the version, remember the docs.ini, and now after we have done this transformation, we can actually create a package. So you can have a look at the project.toml file. Okay, this will help you. It will help you define, what you want to be in the package. Okay, and also in the manifest file. These are the files that you can exclude. So we're saying, for example, include only text files, include, for example, pickle files, include all the files under the Titanic model, include the data file, the raw CSV file, include the trained model, include the version, include the configuration. So this is the configuration, what to include in the package. Now, for packaging, and again, this might be new to you. In fact, the best thing for me to do perhaps is take you to Python create package, and I'll share this link in the group chat if you don't have it, or you can actually Google it. It'll be the first hit, and this is how you can package your Python project. So now, after you have created the structure I was showing you, you will basically need to run this either if you're on a Mac or on a Windows. So upgrade pip. This is similar to the structure I was showing you. So the project.toml file, you can include a README or a license file if you wish. And then, have a look at the TOML file I have. Like I said, you don't have to write it from scratch. You can use my file and then change it, customize it to your needs. Like the version number, the name of your package, whatever you want to name it, the supported Python versions, any classifiers, any URLs, for example, where the packages is, and so on. Okay. After you do that, this is an example package. Okay. After you do that, what you do is you generate distribution archives. Okay. So because we're ready, by the way, when you generate those archives, it'll create the wheel file for you. That's what's used for installation, and it'll also create the tar file as for legacy purposes. Once you do that, you can upload them to somewhere like PyPy, as I say here on the slides, so that the package now becomes ready for installation. You can install it via pip. So once you upload your package, by the way, this is the same link as this one, where Python packages is explained. Okay, so once you create the package, and we'll do this together now live, then you can upload it onto PyPy so that it's installable via pip install. Okay, now for PyPy, you need an account on PyPy. If I go to pypy.org, I do have an account already. So to log in, you need to specify your username and password. That's my username and my password. I can log into my account. Okay? Now, let's have another final look at our model. Okay, at our package. Notice that under my Titanic model, I'm saying the version I have is 0.0.10. Okay, I zoom in a bit. That's my version. Please learn about Python semantic versioning again, because it's going to help you understand what the fields mean. For example, the first field, when it's changed, it actually breaks the API, so that's a major change in the package. The middle field is when we have package updates, and the third field on the right is for small patches in the package. Now remember, this field will break the API. That means the package becomes really different if you compare it with previous versions. Okay, all of this is read in our configuration files. So, hang on a second. Yeah, it should be read in the setup file. By the way, we're using setup tools. In Python, you might find that some people use different things, or sometimes there are multiple ways of doing the same thing. This is from my own experience. I highly recommend following this style. So this is, for example, where you load the version file and then read the version, okay, and save it into this dictionary called about. And then you can set up your package. Okay, so I'm going to stick to version 0.0.10 because I was experimenting before. And then, let me zoom in a little bit now. I am inside the classification model, and then I'm going now to build the package. I'm going to say Python 3 -m build. This is because I'm on a Mac, so I'm following the instructions from here. But I'm on a Mac, so I'm going to build the project. And as you will see here, we will have new folders soon, okay? If you keep your eye on the classification model, we'll have the new folders that contain our package. If you remember the build and the egg files. You give it a few minutes, hopefully not minutes, hopefully a few seconds only. So Python-m build. Okay, now it's copying all the required files. Remember the configuration we said, you can include these files, you can exclude these files. Create isolated environment. Just it's a bit smaller. See that's the name of my package, and that's the version 0.0.10. This is read from that version file. Now, after you successfully build your package like this, see the dist folder? It wasn't there before. And now I have the wheel file and the tar gzip file for legacy purposes. Okay? And that's also generated when the package was built. Okay? Now, after you do this, you can upload your package to PyPy. Remember, under PyPy, you need a username and a password. And for that, you need a Python package called Twine. So if you don't have Twine, let me clear my screen, then install Twine, and the command is Twine. You can do pip install Twine. So Twine, upload, and I'm going to say -r PyPy space dist and then Titanic star, because I wanted to upload these guys here. Okay? And then if I hit enter, it asks me for my username and password. For my username is this. And my password, hopefully I still remember it. Now it'll try and upload, but it'll tell me, okay, there's an error during upload. This is because, see, response 400 bad request. This is because I already have Titanic Survival Model version 0.0.10 there. So if I go to my account here when I log in, okay, I already have the Titanic model. If I show you, I have version 0.0.10. See, I was experimenting before. That's why I have different versions. So saying, you cannot upload the same file. So if I wish to apply a new version, I need to increment the version number and then install it. But now you can easily install my model by doing pip install Titanic Survival Model. And likewise, like so, you can upload your own package to PyPy so that it can be installed via pip. Because we'll need this later on when we create the API for our model. Okay? I hope this part of the training course makes sense. If anything is unclear,